All right, so let's take a look at this starter. And these are all reviews from our past units so that we can understand what still needs to be known for our Unit 5 exam. So first question, a wave will travel only as long as it has blank to carry. Okay, so does a wave carry matter? No. What does it carry? Energy. Good. Now, remember, energy is not matter, so it doesn't have mass. And energy can go through a wave in two different ways. You can have your electromagnetic waves, right? And those are the waves that do not need a medium to travel through. So those would be like light waves and radio waves, microwaves. Those can travel through space. There's nothing in outer space. That's why it's called space. But on other places like Earth, like an ocean wave, needs water to travel through. Sound waves, like you can hear my voice right now, needs air to travel through. So other waves known as mechanical waves, they need a medium to travel through. So make sure you understand it. Those are the key parts to the wave questions. Which type of wave needs a medium to travel through? That's mechanical waves. What does a wave carry? Energy. And then what are the different parts of the wave? Right? You have your crest at the top, your trough at the bottom, between two crests. Does anybody remember what we call that? Between two crests? From one crest to the other, from one wave to the other. Wavelength. Good. And then what about the height of the crest? Amplitude. So make sure you know those different parts. Next, what is displacement? Displacement. Who remembers the quick word that we use for displacement at the beginning of the year?
Shortcut.
Shortcut. Yeah, it's a shortcut. And remember, you've always been told, hey, a shortcut is a shorter distance from where you began to where you ended. And then your PE teachers or someone must have told you at one point in time that the fastest way to get somewhere is a straight line, right? Because you don't have to go around it. Straight line. That's the fastest way to get somewhere. So that's what your displacement is. It's a straight line from where you are to where you want to get going. Now, is that always possible? Take a straight line? No, because what happens to be in the way very often, especially in a town?
Cars.
Houses, cars, mountains, buildings, right? I mean, you can try and go through those buildings, but unless you're the Incredible Hulk, you're going to be stopped. You're going to have to go around. So displacement is the imaginary shortcut, which is not always possible. Sometimes you'll hear older people, I mean like older people, they'll say, it's about 5 miles as the crow flies. They're talking about displacement, like from where we are to where we're going. If you were a crow and you can fly straight there, it's about 5 miles. But driving there, it's going to be a little bit different. So if you ever hear somebody say, as a crow flies, that's what they mean. And then you can probably ask them for some butterscotch candy because they're probably super old. They probably have butterscotch candy in their pocket.
Butterscotch candy is good.
I didn't say it wasn't good. I'm just saying. My grandpa always had butterscotch candy in his pocket. I don't know. Next, what's the average speed of an object that travels 40 meters in 8 seconds? So remember, you have to use the equation. And you have to memorize the equation?
Yeah.
No, it's up there. Right? So what's the equation for speed? Just by looking up at our equation board. Yeah, so speed is distance divided by time. So all you have to do is find your distance, 40 meters, and then divide it by the time, which is 8. So what's 40 divided by 8? 5. And then you steal the units, meters per second. So your answer would be 5 meters per second. And the reason you don't have to memorize that equation is because when you do take a state test, they're going to give you that equation. You're not here to memorize things. You're here to know how to apply them. That's the big difference between 8th grade science and 7th grade science. 7th grade science is memorize this. Tell me what you memorized. 8th grade science is here's the equation. Apply it. Here's a problem. Apply it. Okay, so you don't have to memorize the equation. Just know how to identify the problem and know how to solve it. This one was messing with some people today. The region of influence, right? So what are we talking about when we mean region of influence? What's that? A field force, yeah. From Unit 1. Remember we talked about contact versus non-contact forces. So a field force is that imaginary force field between objects that allow you to move an object without physically touching them. So does anybody remember what type of objects emit a field force that we've talked about?
Magnet.
Magnets, right? What else? Start to the G. Gravity. Gravity is another one. Electromagnets, electricity, all those field forces right there. Did I skip 4?
Yeah.
Oh, yeah. So this one, remember, a quantity that consists of both a magnitude and direction. Think back to Despicable Me. What's the name of that main character, the evil guy? Vector, right? Because he commits crime with both direction and magnitude, right? Direction and magnitude. Number 6. Thanks for showing me I missed that number 4. Now number 6. Blah 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 blah. Buoyant force. Blah 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 blah. Buoyant force. I just want to know what the question's gonna be asking, right? So I can go back and make sense of these numbers. So it's buoyant force. What are some things we remember about buoyant force? Just a few things. Has to do with floating, right? So sinking goes down. We don't want to sink. Buoyant force works opposite of that. So where does buoyant force push? Up. Yeah, if sinking is going down, buoyant force is trying to work up. Does anybody remember the way that you can tell if an object floats or sinks using buoyant force?
Yeah.
Well, but a boat floats, but why? Does anybody remember why?
That's the shape.
The shape, right? The volume's bigger. So remember, you can tell if an object is going to sink or float if the mass of the object, okay, is less than the buoyant force of the object, okay, which is the weight of displaced water. So it says right here, if an object with a mass of 125 grams is placed into a container of fluid and it sinks, what can be said about the buoyant force? Well, the buoyant force must be less than the weight of the object, right? So the buoyant force must be a lower number than the weight of the object. If you want to get super into the answer, you would say the weight of displaced water that the object has is less than the weight of the object itself. But you could just say that the buoyant force must be less than the weight of the object. And then finally, an object in motion will remain in motion unless what happens? An object will keep doing what it's already doing unless what happens? You're going to keep playing video games at your house until what happens? Something stops you. Simple as that, right? And now, is your little brother coming in saying, hey, stop playing video games? Going to stop you?
No.
No, because he's not a greater force, right? Unless you got a super baby brother, I don't know. But so what has to happen in order for you to stop? Just anybody can come in? What's that? Your mom or dad, because they're a greater force than you are, because they can take things away from you. So the same thing happens with objects. Objects are going to keep doing what they're already doing unless a greater force is applied to change that. And that's Newton's first law. Objects be doing what they're already doing. Does anybody remember the nickname we gave Newton's first law? The lazy law. And then what's the sciencey word for lazy? Starts with an I. Inertia. So you can call this Newton's first law. You can call this the law of inertia. Or you can call this the lazy law. But just make sure you know what that means is objects are going to keep doing what they're already doing unless some other force is applied to them, forcing them to change what they are doing. All right. Are there any questions on any of these questions that we've gone over? Excellent. So we're going to go ahead and jump into our Nearpod.